Okay. So kita ni laju sikit lah. Ni sebenarnya lecture note untuk week 5 dah. Tak apa, nanti kita boleh buat perlahankan kelas Mungkin probably I will request to stop class earlier lah. Since today this is our first fasting day. Nak pergi bazar lagi. Okay? Okay, so this is for our today's topic, which is the Exploratory Data Analysis, Eda. Okay, siapa-siapa ada skandal nama Eda tu. Okay, so this is the learning outcome. Okay, at the end of the session, students are able to determine the purpose of EDA, describe the principle of EDA, analyze and evaluate normality and equality of variance assumption. Okay, just a quick review. Where have you seen the term normality? Which statistic? If you may recall from your statistic class, which statistic that require the data to meet the assumption of normality?
Regression
require normality or equality of variance?
Equality of variance.
Regression.
It's normality.
Okay. Then equality of variance, where we always see the term? Which analysis? Ada yang buat sibuk, ada yang buat pandang langit, ada yang buat pandang bawah. Okay, when the statistic involve comparison.
ANOVA.
Okay, for example, ANOVA. If you have any analysis that involve comparison, then mostly we will apply the equality of variance because we know the data distribution between the two or three groups. Okay. Okay. So the purpose of EDA, there are a few purposes. Okay, the first one to get familiar with data. Okay, so we do the EDA ni because we want to know well about our data. Is there any outlier? Is there any missing value? Okay, we know the arrangement of our data. We know that our data exactly falls within the range of the stipulated scale. For example, if we use the scale from 1 to 5, we need to make sure that the key in data falls within this range. Dan kadang-kadang ada because of human error, bila kita nak masukkan kosong, satu kita pergi tekan kosong, for example. So this is one of the purpose of EDA. And then to confirm data has been entered correctly. Okay, kita tak nak ada kosong, ada tersalah masuk. Contohnya the maximum scale should be 5 but we entered 15. Okay. And then to state frequency distribution of a data set, meaning that we want to know, okay, how many, for example, by age, how many respondents for 25 years old. Okay, and then next one, to state the shape of distribution of a data. We want to know either it is negatively skewed, positively skewed, or normal. Okay, we want to check the normality or the shape of distribution of our data. Okay, and then to describe the location of a data, we want to know exactly where they are located. Either it is in first quartile, second quartile, or third quartile. First quartile referring to 25th percentile. Okay, second quartile referring to 50th percentile. Third quartile referring to 75th percentile. Okay. Persen. Berapa persen? Data kita 25% jatuh kat mana? 50% jatuh kat mana? Okay, 75% jatuh kat mana? So basically we just look quarter 1, quarter 2, quarter 3. 25th percentile equals to first quartile. Okay, quartile 2, 50. Quartile 3, 75th. Okay. To describe data variability. Okay, to describe our data dispersion. How does our data disperse? Okay, and then to screen data. Okay, to screening may include the outliers, missing value, extreme values. Okay, and then to identify outlier, and then to ensure assumption of analysis tentatively satisfied. Okay, so these are the purpose of EDA. Okay. Okay, so when we run the EDA, it must be based on two basic principles. The first one is skepticism, means that we do not have any expectation on our data. There might be anything might happen in our data. Itu first thing. We cannot before we run the EDA, we cannot have our early assumption our data have to be normal. Cannot. Because there might be any possibilities in our data set. And then we have to be open if anything. Kalau data tak normal pun, we have to accept. Okay, because there's a lot of researcher, even though their data are not normal, they pretend their data are normal. Okay, dan ada juga yang tak check pun dia punya normality ni. Okay, so either it is normal or non-normal, it should be no problem because for both non-normal or normal data, we have statistic analysis that can entertain that data. So tak payah risau, sebenarnya kita ada option. Okay, so in terms of data requirement, so we need to know exactly about our data. Either it is interval or ratio or is it in categorical form. Okay, because based on the data, it will determine what source, what kind of analysis that we will conduct, what type of output that we can get from the data. Okay, we need to know well about the attributes of our data set. Okay, so first kita start yang pertama, the frequency function in IBMSPSS. Please open your data set, the ERS 5951 that I've shared. Okay, because we will do the hands-on. Okay, because I need to make sure that everybody can run the analysis independently. Okay, so to use the frequency function, just click analyze, click descriptive statistics and click frequencies. Okay, analyze, descriptive statistics and frequencies. Saya harap you all buat tau, saya akan tunggu you all buat, so jangan risau. Okay, analyze, descriptive statistics, frequencies. Then the frequency box appear, then you choose the, by the way, have you recode the PB variable? Dah buat belum?
Not yet.
Not yet. Okay, that's good. Let's
No.
let's work backwards. Okay, sekejap. Sabar je lah. Bukan saya dah tunjuk ke minggu lepas, 2 minggu lepas?
Dah.
Dah tu?
Tak safe.
Eh.
Senangan doktor.
Because this one, this is the data set that you will use to submit your assignment. So when we do the hands-on during the class, you just save because you will use the similar process. Just continue from that process to proceed with the assignment. Okay, so for example, this one. Okay, now first try to get your mean. The mean first. Okay, to compute your mean, okay, first click transform and then click recode. Okay, if you're aware here, there are two types of recode. I'm sure all of you already familiar with these two buttons. I just recall the information in which there are two types of recode. Okay, sorry, tapi kita tak guna recode sebenarnya, kita nak guna compute. Sorry. Nantilah next time lah saya terangkan recode ni. Okay, kita pakai compute. Sorry, transform, click compute. Okay, click transform and click compute. Okay, so under the compute box ni, semua orang nampak kan box compute ni kan?
Nampak doktor.
So saya takut saya tak nampak. Bila saya klik je button baru dia tak nampak. Okay, so under the target variable, you give the name for your variable. So for example, PB_mean. Okay, PB_mean. Okay, and then under the function group on your right side, you click all. Function group, click all. Under the function group, click all. And then scroll down to search for mean. This one, mean, M-E-A-N. Okay. And then double click. Okay, double click and then these two question mark appear in your numeric expression. Okay, so then just highlight this two question mark. Okay, just highlight the two question mark, and on your left side, you double click the PB1. Okay, double click the PB1, comma, double click the PB2, comma, PB3 until PB8. So far so good?
Yes, Doctor.
Okay. Make sure,
Okay.
okay, then click OK. Okay. Then on your data set now, you can see there is a new variable. So this is the variable that we will use. Okay. This is the first one. Okay. And then try yang the rest tu buat sendiri lah For copying, later there will be instruction in your assignment. Just follow the assignment. I just show one. Satu je saya tunjuk. The rest, you should follow the similar step. Okay. The next step is to come up with the categories. This one is the mean. Okay, the values that will represent the philanthropic behavior. Okay. In your research objective, if you aware the first objective, most of researchers state, what is it? The first objective in your research, in your dissertation for quantitative research. What is the first objective?
The level of
The
DB.
level
How we can determine the level?
by mean. Interpretation of mean.
By mean. How we can do it by mean, Alia?
Categorized into
Category.
Okay. 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 Sebenarnya kan, lecture note ni saya ambil daripada saya mengajar sem lepas punya. Saya perasan kenapa tiba-tiba ada satu slide yang tak ada mark ni kan. Saya perasan kenapa ni. Lepas tu saya letak kat belakang ni. Lepas tu saya bila buat tadi baru saya tahu fungsi slide ni. Okay. Okay, so we need, when we want to determine the level, okay, so actually we need to come up with new categorization for our data. Okay, when we want to determine the level, we need to come up with a new categorization for our data. Okay, so this data, okay, this data, what is the scale of measurement now for PB mean? What is the scale of measurement for PB mean? Now. Interval. Yes. The earlier scale of measurement of philanthropic behavior, which is in item, this one is in ordinal. But now it is in interval. Okay, so this one will represent your individual variable for philanthropic behavior. This one will represent the individual variable for philanthropic behavior. As what I indicated earlier, if you want to determine the level, then you need to come up with new categorization for your data. Okay, so the categorization will depend on how many classes that you want to establish. Is it low, moderate, high, or is it only moderate and high, or is it low and high? Depend. This class depends on your how many categories that you want to establish, how many categories that you want to create. But in general, we only use three level: low, moderate, and high. Low, moderate, and high. Okay. Then after we establish these three categories, we need to decide on interval. Okay, this one is interval. Okay. Okay, so we need to decide on interval. So how we can decide on interval? What formula we can use?
Divided by 3.
Apa? What should we divide it by 3?
The highest score minus the lowest score and divide by 3.
Okay, very good. Okay, so the highest score, highest score minus lowest score. Oh, this one divide by number of classes. Number of classes. So for this example, our Likert scale that I've used is 5. The minimum is 1 equals to 4. Okay. Divide by the number of category that I use is 3. So equals to 1.333 infinity. Okay. So 1.33 infinity, but you still need to decide the endpoint. Either it is 3.3331 or it is 1.3334. 3334. Up to you. But you need to decide the endpoint. Okay. Why? Why we need to decide the endpoint? Because we do not want later after you insert your data, okay, there might be clash, redundancy. Okay, because when we set our class, we need to make sure that the two group need do not redundant. Okay, so now then when you want to set your level, so you just add 1. Okay, 1 plus 1.33, so equals to 2.3331, for example, 331. Okay, and then this one to start with 2.332. Okay. 1 plus 1.33, 3.665.
661.
3.665. Okay, and then 3.66 to 5.
6.
Okay. 665.
Okay, Doktor.
666. Okay, 666. Okay, make sure that it is redundant. Not redundant. Okay. So we have this scale. Okay, so we already set this one. Now we need to recode our data. Okay, we go again to our data set. Okay, now we need to recode this one to come up with new category. To recode this one, only then we click analyze, click transform, click recode. Okay, so again we have two types of recode here. Either it is recode into same variable or recode into different variables. If you select recode into same variables, means that after you do the categorization, the new categories will replace the existing variable. The original variable will no longer exist. Okay, but if you use recode into different variable, you will retain your original variable, but the data set will add on a new variable, which is the category.
Oh, patutlah.
Patutlah tak ada. Okay, so I always recommend you to use recode into different variable, because if anything's wrong in your data set, then you can check again. But if let's say the original data missing, then you need to do it again. It's okay if let's say you just need to do the transformation here, but what happened if you replace the data set here? If you have around 300 respondents, so you means that you need to key in again.
Punah.
So be careful before things go wrong. Okay. So now, okay, we go to our variable view. Okay, to apa pula variable view? Kat sini je lah. Okay, click transform. Okay, and then click recode into different variable. Transform, recode into different variable. Okay, and then you choose the variable. For example, PB min. Okay, if you have more than one variable and then the categorization is similar, then actually you can do it at one shot. Boleh je masukkan banyak-banyak. Okay, but in this case, because I already have one, so I just show one lah. Okay, so now after you select your variable, locate under this box. Okay, then you need to rename the variable. Okay, then now you name into PB underscore cat. PB category. PB underscore cat. And then click change. PB underscore cat and click change. Okay. And then now click old and new values. Click old and new values. Okay. So under old and new values, okay, you select range. Okay, select range. Okay, activate the range button. Okay, now you insert your interval. So 1 until 2.334 tadi. 334 ke 331?
331. Betul.
331. Okay, so 2.331. So this one for old value, the new value will be 1. Okay, and then click add. Okay, next one, 2.332 until 3.665. New value will be 2. And then click add. Okay, and then lastly, 3.666 until 5 will be 3. By why 1, 2, 3?
The category, the level.
3 category.
Why 3 category?
Level.
Why level?
Level. Low, moderate, high.
So if you can recall the coding that we discussed last few weeks. So now you already know what 1 represent. 1 represent low, 2 represent moderate, betul lah? 3 represent high. So that what is it? What it means by coding, code book. So you know 1 equals to low, 2 moderate, 3 high. Okay, so sebab kita tak boleh type kat sini, moderate kat sini tak boleh. Tak boleh tulis kat sini. Cannot. Okay, we can only use numbers. Okay, so 1, 2, 3. So then after that, click continue. And then click OK. So then in your data set, you can see new variable, which is on PB cat. Okay, so this is for the category. Okay, this is for for the raw data. Clear?
Save,
Yeah.
save.
Okay, senang ya kan? Senang je. Okay, so next one. Okay, hak ni nantilah kita belajar kemudian. Hak ni kita belajar kemudian. Yang penting hak ni dulu. We are done with this one. This one later. Okay, back to our topic. Okay, this one. Okay, now, okay, click analyze. Now because we are done with our data, now you can click analyze, click descriptive statistic and click frequency. Analyze, descriptive statistic, frequencies. And then after the frequencies box appear, okay, select the PB variable, PB mean variable. Okay, locate on your right side. Okay, and then click statistic. On your right side, click statistic. Okay. Okay, make sure you check for mean, median, mode, and sum. Okay, and then check for under the dispersion, you check for standard deviation, variance, range, minimum and maximum. Okay, and then for distribution, you check for skewness and kurtosis. Okay, quartile. For percentile to let it be on quartile. Central tendency, mean, median, mode, sum. Dispersion, tick for all except standard error for mean. Okay, and then for distribution, tick for both skewness and kurtosis. Done?
Done, Doctor.
Okay. Then click OK. So this is your result. Correct?
Alright.
Okay, so this is the result. Okay, so based on the result, what we can interpret is first your mean. Okay, the mean value. Okay, sorry. The first one is the valid case. Either if there is a missing value or not in your data set. If there is a missing value, then it will stated here. But in this case, there is no valid, there is no missing value. So all the cases are valid. Okay, and then for mean. Here, this is the average of your data set, 3.8563. Okay, so the mean value. Okay, mean median mode ni will represent your measure of central tendency, MCT. Okay, mean, mode and median. Okay, next one, standard deviation and variance ni will represent your dispersion, measure of dispersion. Okay. And then we have the skewness and kurtosis. Okay. Nama. Terlaju pula tekan. Okay, so we have the skewness and kurtosis. So based on the skewness value, the value is 0.742. Okay, so if we compare based on the plus minus 2, it is still within the range. It is within the range of normality, which is plus minus 2. So this one 0.742. So it is still within the range of plus minus 2. So therefore, it is positive, it is slightly positively skewed, but still considered to be normal. Okay, because it still falls within the range of plus minus 2. Okay, so this one kurtosis. Okay, so the cut-off point for kurtosis is plus minus
7.
7. So now based on the word data, it is 0.035. Okay, so 0.05 ni, it is considered to be leptokurtic. Sorry. Less than 0, larger than 0, leptokurtic ni. Ni, this one platykurtic. I still remember this one, mesokurtic, leptokurtic, platykurtic. Bila saya sebut ni saya ingat apa tau? Saya ingat apa tu ada yang pokok dalam SpongeBob tu. Okay, so mesokurtic, if let's say the value is larger than 0. Larger than 0, leptokurtic. Okay, and then this is the range. Okay, this is the minimum and maximum. So this is the minimum and maximum score for your data set. So the maximum will be 5, the minimum 2.88. So you should know that if the value here larger than 5 or lesser than 0, lesser than 1, so there's something wrong with your data set. Okay, if you got the value here larger than 5, lesser than 1, means that you need to check again your data set. Okay, and then the range, okay, the value of range ni, the maximum minus minimum, you will get the range. Okay, minimum minus maximum, maximum minus minimum, you will get the range. Okay, the sum, the total of your data set, and then this one is the quartile, percentile. Okay, 25 ni Q1, 50 Q2, and then 75 Q3. Okay, this one will be the basis for your box plot. Okay, box plot. Okay, the percentile will be used as a basis to create your box plot later. Okay, so far any question? Senang je kan?
Senang pula. Okay.
Alhamdulillah, senang. Okay, so next one. This one, frequency. Now descriptive function. Okay, there is actually a redundancy between descriptive function and frequency function. Ada some redundant. Okay, so to come up with frequency function, you just go click analyze. Okay, saya pun lupa ni. Yang penting click analyze.
Descriptive.
Okay, so dia ada kat button yang sama. Analyze, descriptive statistic and click descriptive. Analyze descriptive statistic and click descriptive. And then you just choose the PB mean. Okay, choose the PB mean. So for under option ni tak ada apa, dia sama je. Okay, so mean, sum, standard deviation, variance, range, skewness and kurtosis, similar thing. Then just continue and then click OK. Okay, so this is for your output. So this is output. Okay. So the button the function for descriptive and frequencies is actually quite similar. Okay, if you compare, okay, they have the value for statistic. This one the valid case. Okay, valid case in in frequency pun ada range, yes, minimum and maximum. Some statistic ada mean statistic, mean yes, standard deviation yes, variance yes, skewness and kurtosis yes. So what's missing in descriptive compared to frequency? What is missing?
Percentile.
Yes, percentile. Okay, itu sahaja yang membezakan. That is the only differences between descriptive and frequency. Okay, so if you want to come up with the meaning, you can either use the function descriptive or frequency. Itu maksudnya kat situ. Okay, either one, sama je function dia. Okay, so next one. One, ni dah. Okay, so next one, explore function. You go through the similar function, analyze, descriptive, but click explore. Okay, analyze, descriptive, explore. Okay, after the explore button appear, then you choose your PB mean and locate under the dependent list. Choose PB mean, locate under the dependent list, and then click plots. Salah, ni bukan plots ni, kena klik statistik. Klik statistik. First klik statistik. Okay, klik statistik. Okay, so under statistic, you take for descriptive, outliers, and percentiles. Descriptive, outliers, percentiles. Okay, and then for the confidence interval ni, let it be as at 95%. And then click continue. Okay, and then next one, click plots. Next one, click plots. Okay, for the plots, you choose these three functions. For box plot, let it be for factor levels together. For descriptive, choose term and leaf, and then histogram, and then tick for normality plots with test. Done? Okay, so done. Click continue and then click OK. So this is the result. Okay. The first table is case processing table. It will provide you with the information of data validity. Okay, how many percent of your either there is a missing value or not. Okay, and then next one is they will provide you with the the mean value here similar. The mean value here should be similar with the mean value in descriptive and frequency. Similar thing. Okay, and then 95 confidence interval for mean. Okay, and then 5% trim mean. 5% trim mean ni, if let's say your data, okay, this is your data 1 to 200, sorry 1 to 100. Trim mean ni after they trim 5% top and after they trim 5% bottom. So leave your data 90%. Okay, so mainly based on 5% trim mean. So it's stated that 3.838 your data located within the range of 90%. Okay, this one median should be similar from earlier data, variance similar, standard deviation similar, minimum, maximum similar, range, interquartile range. What is interquartile range?
Between the quartile.
Apa?
In between the quartile.
In between the
range.
quartile. Okay. Aduh, quartile range. Q3 minus Q1. Interquartile range ni Q3 minus Q1. That it means by interquartile range. Q3 minus Q1. So the answer is 0.742. Sorry. 0.3 Q3. Okay, if you want to check this one, okay, you go back to this one. Okay, try minus 4.125 minus 3.5.
0.625.
0.625. So the value should be similar to here. But this one is already around to the close value lah. 6.3 ni. Okay ni. Okay, Q3 minus Q1. So you will get the interquartile range. Okay. The skewness and courtesies should be similar from previous data. Sama je. Okay. So the additional here, you will get the 95% confidence, 5% trim. Okay. And then interquartile range. The rest should be similar. Okay. Okay. So next one. Oh, so you have another result. So this is another result. You don't have this one? Ada
Ada doktor.
Ada
okay,
test
so
of
this,
normality.
so this one, apa tu, the detailed description of the earlier table lah. Okay, so you have the tabulation according to the percentile. Okay, so this one, so the third quartile. This one Q2, this one Q3, this one this one Q2, this one Q3, this one Q1. 25 to Q1, 50 Q2, 75 Q3. Okay, so this is the tabulation, the data tabulation. Okay, so next one, the extreme value. This will indicate the value that is located beyond the average in your data set. Okay, so these are the case number of the score. Faham tak extreme values? Okay, extreme values ni actually the score that located beyond your average score. Okay, for example, the normality is between 25 to 75, between 25 and 75 percentile. But this value ni falls outside the range. Okay, this value ni falls perhaps this range here or here, outside this range. Okay, so this value is considered to be extreme values. The values that will influence your data, and it might be cause your data become not normal. Okay, the extreme value ni can influence your data, in which the availability of extreme values in your data set may result in non-normality of data. Okay, dia menyebabkan data kita tak normal bila ada extreme value ni. Okay, so this case number ni will represent the number of respondent. Bukan, will represent respondent number. Case number ni represent the respondent number. Okay, if you want to delete, if you think that you want to delete the case, then you can delete the respondent number 31. Okay, ini bilangan respondent. Okay, faham? Okay, so next one is test of normality. Okay, as what I indicate earlier, other than skewness and courtesies, we can check the normality based on Kolmogorov-Smirnov and Shapiro-Wilk. Okay, so this is the test that we can use for normality. Okay, so the cut-off point that we use is apa dia? What is the cut-off point? Kuatlah, hujan lebat sungguh kat luar. Okay. Okay, so the guideline that we use is if the significant value, if the significant P, if the significant value larger than alpha, the data considered to be normal. If the significant value lesser than alpha, the data considered to be non-normal. Okay, so based on the Kolmogorov-Smirnov, the one that we want to refer to is the significant value, this one. Okay, so this one we compare against alpha. Okay, so alpha, for example, we set at 0.05. Okay, so we set alpha at 0.05. So this one indicate data normal or not? Or non-normal?
Normal.
Huh?
Normal less than
Non-normal.
Not normal.
Not normal. Tengok betul-betul Adi. Okay, the rule is if significant value larger than alpha must be normal. Okay, so now this value is lesser than alpha 0.05. So it is not normal. So similar to Shapiro-Wilk, if the significant value larger than alpha, then the data considered to be normal. If the significant value lesser than alpha, therefore our data not normal. Okay, so basically, okay, it is quite difficult for us to reach to meet this to meet this statistical target. To meet the Kolmogorov-Smirnov and Shapiro-Wilk, it is very difficult for social science researcher. So that's why most of us will use the alternative, which is either skewness or kurtosis. Okay, sebab susah sangat nak dapat ni Kolmogorov-Smirnov and Shapiro-Wilk. Okay, tertutup lah pula. Okay, so next one, histogram. Okay, so this is the histogram. Okay, the histogram also can be one of the alternative to check for normality. Okay, you can just draw the graph according to your histogram. Okay, so you can just draw your graph according to the histogram. Okay, so based on the graph ni, it also can consider to be normal because it sounds like bell shape. Okay, next one is by using stem and leaf plot. This one, stem and leaf plot. Stem and leaf plot also quite similar with normality plot. Okay, if you just draw the value here, it also represent the bell shape. Okay, this one is considered to be the cases, the case. The case. One, how many? Okay, the case. Okay, next one. Ni option. Selain daripada skewness kurtosis, you also can report the histogram and stem and leaf plot. Okay, dua-dua ni boleh digunakan. Okay, next one, normal QQ plot. Okay, mana dah? Okay, so this one also can be used to report on your normality. Okay, to report on the QQ plot, you just compare the dots here, the data distribution here against the straight line. The straight line ni. Okay, if the data set falls within the straight line, your data considered to be normal. Okay, if the dot here falls within the straight line, your data considered to be normal. Okay, so then this one also you can report. Similar to the trended normal QQ plot, okay, if the data set falls within this straight line, your data considered to be normal. But according to the current trended QQ plot, your data are just like wave. This sound not normal. So jangan report. Okay, next
So you
one.
only report the normal one, doctor.
Only report the data that support whatever you want.
Oh.
Okay?
Doktor,
Yes.
doktor.
Mm-hmm.
If possible, doktor kalau box plots tu normal and then the skewness and bacaan kurtosis and Shapiro tu tak normal, so kita boleh pilih salah satu mana yang normal.
Okay, first you have the option either you want to check, you want to report either one. But at your level, okay, we can actually process our data further to double check If let's say it is not normal, if most of the statistics indicate that it is not normal, then why not we do the next step, which is the transformation. Later I will share. Okay, but you have option just to report the box plot, but it is the most basic one lah. The most basic one, which is you still report the one that support your interest, which is you want to do the parametric analysis, then therefore your data, you need to prove that your data are normal. Itu maksudnya kan? Because you want to use parametric statistic, therefore you need to indicate the result that support your intention, which is you want to use the parametric. So first, ingat tadi prinsip bila kita buat EDA tadi, kepala kita mesti open. Okay, because we need to remember that for either data normal or non-normal, we still have options for both data. Kita ada analisis statistik for both. Okay. Okay. So next one is box plot. Okay, so this is the box plot. Okay, so they create the box plot ni, it is based on the quartile. 25, 50 and 75. Okay, so this one is the median. And this one is median. This one is 75 percentile. This one 25. Okay, tengah-tengah ni should be the 50. Okay, based on our current data. Okay, if let's say the median ni located at the bottom, so it means that it is positively skewed. Okay, kalau dia kat bawah ni positively skewed. Saya rasa saya terbalik last week. Okay, saya terbalik last week. So saya betulkan balik, if the arrow located at the bottom, at the downside, so it means that your data are positively skewed. Okay, kalau ke bawah. Kalau atas ni negatively skewed. Okay, so next one. Okay, outliers. How we can determine the outliers? Okay, so first outliers ni refer to any points that falls below Q1 minus 1.5 times interquartile range or above Q3 plus 1.5 times interquartile range may be considered to be an outlier. Okay, ni maksud dia. Dia kata outlier ni can be any point that falls below the quartile range minus 1.5 times interquartile range. For example, I come up with the calculation here. For example, our first quartile 1 is 3.5. So this one I thought you can get from our data set. Q1 under the frequency. Okay, frequency analysis tadi, frequency function, then you can get the quartile 1 is 3.5. Quartile 2 3.75 and then quartile 3 is 4.125. Betul?
4.125. Yes.
Okay. So to then first you need to calculate the interquartile rate. So you just minus Q3 minus Q1. So you will get the 0.2625 or 0.263 if you use two decimal places. Okay. Boleh Next one, you just plug in the information here into the equation. Okay, so Q1 minus 1.5 times interquartile range. So Q1 3.5 minus 1.5 times 0.625. Okay, so the answer is 2.5625. Okay, 2.5625. Okay, 2.5625. 2.5625. Okay, so this is for the first quartile. Okay, so next one is quartile 3. Okay, so this one, sorry, sini kat bawah. 2.0, 2.5, 625. Okay, now calculate the second interval, which is quartile 3 plus 1.5 times interquartile range. So you just plug in the value. Quartile 3 equals to 4.125 plus 1.5 times 0.625. So the answer is 5.0625. 5.0625. Okay, dapat? Did you get the answer?
Dapatlah, doktor.
Dapat tu buat ke tak?
Pakai kalkulator biasa.
Pakai kalkulator biasa, tak apa. Saya pun ada juga ni yang besar ni, yang dua ni. Samalah, sama. Okay, right, dapat tak? Okay, so you have the two range. Okay, 2.5625 and 5.0625. But just to ask, okay, is it possible for us to get the value of 5.0625? Possible tak ni? Is it possible? Why? Why, Fatin?
It is more than our liked scale.
Yes. Okay, it is more than our liked scale. So we supposed not to get the value beyond 5. Okay, but then means that we know exactly that any value that beyond 5 shouldn't exist lah, but it is considered to be outlier. Tapi tak sepatutnya tak ada. Okay, here. Okay, so if you have the outlier in your data set, what should you do? Omit or remain?
Omit.
Omit.
Kalau macam tu,
Kalau macam tu, saya dengar. Okay, omit or remain. First, I cannot answer that. It depends on your data set. If you have exactly the minimum number of sample, be careful before you omit. Okay, so means that I do not advise either to omit or remain.
kalau macam tu kan tak nak tahu.
Sayang. Okay, I do not advise either you retain, either you omit or retain. It depends on your data set. If let's say you have a minimum number of data, make sure you already fully considered either it is to retain or to omit. Okay, first you need to make sure that first you need to make sure that during your data collection you have ample number of sample. Okay, so that's why bila kita buat data collection, make sure you have more. Okay, you consider more in your data set. Okay, so that you do not have the minimum number. Okay, and then if let's say after you run the analysis and then you found out there is no correlation between your variables. Okay, if there is no correlation, then you may check your EDA, exploratory data analysis. You may check your descriptive data, either it is normal or non-normal. If let's say it is non-normal, then you may consider to transform before you omit. Okay, you may consider to transform your data before you omit. I will share on how you can do the do the transformation. Okay, so next one, first this one maksudnya means that you perform the analysis with and without the outlier. You try to perform both, okay, the data with the outlier and without the outlier, then you compare. If the result is similar, then you means that you can retain. If the result different, then you may consider either to transform or omit. This is my suggestion. Okay, sebab kadang-kadang kita tak naklah omit kalau kita tak ada sample size yang cukup. Takut data tak cukup. Okay. So, in overall when we conduct the statistical analysis, there are 3 statistical assumptions that we need to fulfill. Okay, so assumption of normality, in which most of if you want to use the parametric statistic, then you need to make sure that your data are normal. Okay, so either which method that you want to prove normality depends on you. Either you want to use Kolmogorov-Smirnov, Shapiro-Wilk, skewness, kurtosis, what else? Box plot, QQ plot, okay, stem and leaf, up to you. As long as you can prove that your data are normal. So in terms of reporting, my suggestion is you report the findings that support your data. Do not report something that against your data. If you want your data normal, then make sure you report the result that support the normality of your data. Okay, do not jangan tikam diri sendiri. Okay. Okay, next the next one is assumption of equality of variance or homogeneity of variance. Okay, in which we require this assumption when we want to compare between groups. Okay, and then next one, assumption of linearity. Where we use this one? Where? Kat mana kita guna? When we use the multiple linear regression. Okay, when we use the multiple linear regression. Okay, so next one. Okay, so assumption of normality, actually I already present a few. Okay, so to support the assumption of normality, either you can use graph, okay, in which it is useful for looking at normality in big sample. Okay, so you can use the PP plot. Okay, you can take advantage of PP plot if you have large samples, for example 300 and above, for example. Okay, so if values falls within the diagonal of the plot, then the variable is normally distributed. So if the data set is consistently above or below the diagonal, then this shows that the kurtosis differs from a normal distribution. If the data points are S-shaped, then it means that the data are not normal lah, non-normal. Tak habis kat bawah ni. Okay, next one. You also report the normality based on numbers. So in which either you use the skewness, kurtosis, Kolmogorov-Smirnov, and Shapiro wheel. So skewness and kurtosis, we use the cutoff point plus minus 2, and then for kurtosis, we use the plus minus 7. Okay, meanwhile for the Kolmogorov-Smirnov and Shapiro wheel, we use the we compare the value, the significant value against alpha. Okay, significant value. Ada siapa-siapa? Is there anybody who still confused between significant value, significant P, significant T, significant F? Ada siapa-siapa lagi confused lagi ke dengan ni? This value? Significant P, significant T, significant F, significant values. Ada lagi? Is there anybody who still confused between all these terms? Okay, tak ada masalah.
Cerita sikit boleh?
Boleh.
Yang similar je lah untuk refresh.
Okay, boleh. Okay, so it actually just represent the type of a specific type of statistic. If you use the significant P, this one is general term to represent the alpha. Okay, the alpha that we set, significant value that we set. Sorry, this one significant P ni is just represent the general term for this significant value, general term. Okay, similar goes to significant value. Okay, similar general term. Okay, but sometimes we use the significant P, and then sometimes significant F. Okay, this one it just represent the statistical family. The statistical family of the test. Okay, if you use t-test, for example, if you t-test the family of t-test is T. Yes. Okay, and then but if you use regression, F. This one referring to ANOVA. Regression kita pakai F tau. Okay. Similar to regression. Regression also T. Significant T. Okay, it just represent the family of the statistic. The statistical family of the analysis too. Okay, but in general, it just reflecting similar thing. Okay, Amen. Yeah. Okay. This one, no problem. If you have any problem, please let me know. Okay, next one is assumption of equality of variance, in which we use this assumption when we want to check for comparison. Any comparison between level, within level, okay, within one group, within two group. Okay, so the statistic that we use is Levin test or Levin statistic. Okay, Okay, we test the test homogeneity of variance by using the Levin test, Levin statistic. Okay, so when we come up with this analysis, we refer to the significant value. Okay, we refer to the significant value here. We compare the significant value here against alpha. Okay, so alpha similar to your statistic class, we use either 0.05 or 0.01. Okay, either 0.05 or 0.01. So this one is most regularly used in social science. Okay, so the value ni we compare against alpha. If the significant P, if the significant value larger or equals than alpha, data met the assumption of equality of variance or homogeneity of variance. If the significant value lesser than alpha, therefore the data does not meet the assumption of homogeneity of variance. Okay, sama je. Equality of variance or homogeneity of variance, sama. Okay, term yang sama. Okay, so next one. Hari ni kita stop pukul 5 boleh? Di bazar lah.
Boleh doktor, saya pun nak pergi bazar doktor.
See you all tak masak, dah tahu dah.
First day puasa doktor.
Ya, faham. Okay, so next one, assumption of linearity. Okay, so assumption of linearity ni some of analysis, for example, regression, multiple linear regression, needs the relationship between the independent and dependent variables to be linear. Okay, kalau kita guna multiple linear regression, that's why the name is linear. So means that we want to make sure that the relationship between IV and DVs are in straight line, linear. Okay, it shouldn't be like wave. Macam kalau apa tu, logistic regression, that one lain. Okay, so the linearity assumption can best be tested with scatter plot. Okay, so for to test the assumption of linearity ni, we only can come up with scatter plot. So the name for this one is scatter plot. Okay. So actually we can test, you can test to try to come up with the scatter plot for philanthropic behavior by using this step. Okay, IBMSPSS, then you click graph and then click legacy dialog. Cuba buat. In your in your SPSS. Macam mana nak tutup ni? Click graph, click legacy dialog and then click line. Scatter dot. Sekejap
Kat bawah sekali ada scatter
betul.
dot.
Scatter dot. Betul, scatter dot. Okay, sekejap saya share. Okay, so click graph, click legacy dialogs, click, alamak tak nampak ni. Click scatter dot. Okay, graph, legacy dialogs, click scatter dot. Okay. And then click simple scatter. Oh, tak boleh jugalah. We cannot do this because we do not have another variable. Okay, tak apa, saya buat kejap Saya buat kejap. Okay, I just come up with this is the DV. I try to get the mean for another IB. By the way, bolehlah you all nak buat tak ni? Buatlah sekali social trust. Okay, we do the social, we get the mean for social trust. Click transform, click compute variable, transform, compute variable. Okay, and then after the target, after the compute variable box appear, then you just put the name social trust, st underscore mean. So under the numeric expression, you just delete all the PBs. Okay, and then replace by social trust, ST. There are only 5 items of social trust. Okay, you just locate the first variable and space, type 2, space, ada 6, sorry, social trust. Why Yong, why you are smiling? Okay, boleh? Can? This is another way to get the mean. Okay, so mean, you just click the first variable, the first item, and then space, type 2, TO, and then another space, and then just locate the last item. This is the more shortcut. Okay, and then click OK. So then as you can see in your data set, you will have a new variable. Okay, so then we will try to test the linearity between social trust and philanthropic behavior. To test the linearity between this one, so just click graph and then click legacy dialog. Okay, click graph, legacy dialog, and then click scatter dot. Okay, graph, legacy dialog, and scatter dot. So then after the scatter dot box appear, choose simple scatter and then click define. Click choose simple scatter, click define, and then locate your variable according to the function. Y-axis will represent your dependent variable. Okay, y-axis represent your dependent variable, which is philanthropic behavior. X-axis represent your independent variable, which is social trust. Okay, and then just click OK. On the way, running the graph. Okay, so this is the graph. Okay, so this is the graph. Double click this one. Mana dia punya function tu? Okay, double click this one and then locate. Locate the straight line. Okay. So this is the
Doctor, again, how you do the straight line? How you locate the straight line?
okay, double click on this graph. Double click. Okay. 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 Dah banyak line dah saya draw ni, aduh. Okay.
Doktor tak keluar lah property box macam doktor tu.
Keluar? Okay, tak apa. Sekejap. Kejap. Okay, so this is the one This is the one. Double click here. Anywhere in the graph. Okay, double click. You can see? Boleh tengok tak? Boleh nampak? This one.
Dia keluar properties.
No. Okay. Just close that one. Just focus on the heading here. Just focus. Saya nak drawing. Just focus on the heading on the activated graph ni. You nampak tak graph saya aktif ni? Can you see the activated graph?
Oh, dia macam ada macam gray kill the whole graph, but tak ada box yang menyatakan locate straight line.
Okay, it's okay. You just refer to your heading. Ni.
Oh, chart editor ke?
Yes, under the chart editor. Okay, under the chart editor, you just activate that one. Okay, and then mana tadi? Saya tadi keluar. Okay, and then on your right side, you click on the line that add fit line at total. Ni.
Okay, done.
You click that one. Okay, so you will get this one. Correct? Y equals to 4.25 minus 0.1x. Adi dapat? Adi Putra dapat?
Dapat.
Yong? So everybody else, did you get this one?
No, Doktor.
Tak dapat.
Okay, first double click this one. Okay, double click, activate this this graph. Double click, kena klik dekat sini juga. Jangan klik kat luar, kena klik kat sini. Okay, double click and then after that the chart editor appear. Correct? Correct?
Yes.
Okay, so after the chart editor appear, you check on your heading above tu, dekat atas tu, on your right side. Jangan tengok on left side tu, on right side. Okay, there are few activate buttons with green color, correct? There are few graph symbol with blue color, blue color. Okay, nampak tak? Saya tak tahu kenapa you all tak nampak saya punya yang ni, this one ni. Ni kot.
Kat bawah tu lebar.
This one. Can you see now? Chart editor? My chart editor?
No. Yes.
Okay, you check this one. Add fit line, add total. Click this one.
Oh.
Okay, and then close. Okay, close. Then now it is there in your chart, in your graph. Okay?
Okay, dapat.
Okay, so this is actually the linear regression between the linear equation between the social trust and philanthropic behavior. Ni, y equals to 4.25 minus 0.1x. So means that there is a negative relationship between social trust and philanthropic behavior. Means that the more you trust the person, the more the less tendency for you to involve in volunteerism. Ini maksud dia. Okay? Dapat Okay, so I thought we stop here lah for today. Saya nak stop here lah hari ni, penat lah. Okay, is there any question?
Tak ada question doktor, tapi cuma nak minta jasa baik doktor, tolonglah share video yang pada hari ini. Sebab dengan hujannya, dengan apanya, macam ya Allah, macam kenapa nak try dekat apa, nak try apa yang doktor ajar apa. Dekat ni pun macam tak buat doktor bila ingatkan macam nak buat lah kalau doktor share ni nak ikut balik step by step. Memang lost lah hari ni doktor, maaf lah kelas hari ni.
Boleh, no worry. Saya pun memang sebenarnya menunggu sebab tak ada orang request untuk share. So saya diam je, biar je. So
Ada doktor, kita tiap-tiap minggu request.
Okay, hari ni saya post. Saya rasa this is quite important, so I will post. Sebab apa saya macam sajalah nak bagi tahu sebab saya dah beli komputer baru kan. So komputer ni laju sikit. So saya boleh dah buat edit sikit. InsyaAllah nanti saya share. This one for this
Doktor
week.
nanti share dalam group WhatsApp boleh tak? Sebab dalam Putra Plus kita yang drop tu memang dah tak nampak lah kalau share
No
kat
worries,
Putra Plus.
I will post in my YouTube channel.
Wow, okay. Nanti kita follow YouTube doktor.
I will post there so that everybody can see. No worries. Okay? So if there is no more question, we stop here. If you have any query, just post in our group. InsyaAllah I will entertain. Okay? Okay, so take care guys. Happy fasting. Selamat berbuka. Take care. Bye. See you next
you.
week.
Assalamualaikum.
Selamat berbuka doktor.
Thank you.